Hello and welcome to another Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 1, Lesson 6 on Linear Equation Solving Review. A lot of what we do at the beginning of Algebra 2 will be review in terms of algebraic techniques and terminology and even calculator work that you're going to need going forward. So let's jump right into it and do a little review on how to solve linear equations. Now, we will learn new equation solving techniques in Algebra 2, but the most basic of all equations are those where the variable, let's say x or whatever, is only raised to the first power. These are known as linear equations. Now, you need to have fluency with solving these types of equations to be successful in the beginning portions of Algebra 2. And of course, you've been solving linear equations probably since about 6th grade math. So, you've been doing them for a while, right? So let's jump right into it in exercise 1 and remember how to solve some linear equations. Exercise number 1. Solve each of the following linear equations for the value of x. All right, now awesome. Now I know you've done these things before, so what I'd like to do is have you pause the video and really quickly see if you can solve letter A. All right, well, letter A is one of the most basic types, which is called a two-step equation. We've got 3x plus 5 is equal to 26. We simply need to reverse what has been done to x in the opposite order. Now, the way that we're going to do that is we're going to first subtract 5 from both sides of the equation. That's going to give us 3x is equal to 21. And then we're going to divide both sides of the equation by 3, and we're going to get x equals 7, right? The whole idea in that type of an equation solving technique, and this is an important big concept idea, is that x has been multiplied by 3 and then had 5 added to the result. To undo that, we then first subtract the 5 and then we divide by the 3. All right, let's take a look at letter B. 8x minus 7 is equal to 4x minus 5. All right, so this is a classic situation where we've got the variable on both sides of the equation. Again, something that you've been doing a lot of since about 8th grade math. So I'd like you to pause the video now and see if you can solve this particular equation. So generally, when we have variables on both sides of an equation, we try to move all the quantities with variables to one side and all of them without variables to the other side. So in this situation, what I'm going to be doing is I'm first going to be subtracting a 4x from both sides. So that's going to give me 4x minus 7 on this side is equal to negative 5 on that side. And now I'm really back to a situation where I was like in letter A, a two-step equation where I'm going to add 7 to both sides, and I'll get negative 5 plus 7 is 2. And then I'm going to divide both sides by 4. Now be careful in a situation like this. It's easy to think 2 divided by 4 should be 2, but in fact, that just reduces down to our favorite fraction, x equals 1/2. All right. Now, letter C is actually more analogous to letter A. It's still a two-step equation. Let's take a look at it really quickly. In this equation, we have x plus 8, the quantity, divided by 2 is equal to negative 6. So yet again, we don't have variables on both sides of the equation, only on the left-hand side, and there's two things that have been done to x, right? First thing that was done was x had 8 added to it, and the second thing that was done was that quantity was divided by 2. I'd like you to pause the video now and reverse those two operations to figure out what the value of x is. All right, well, the first thing that we need to do is undo the division by 2. So I'm going to simply multiply by 2 on both sides. All right, that undoes the division by 2. So I get x plus 8 is equal to negative 12. And now, simple enough, I just need to subtract 8 from both sides, and I'll get x is equal to negative 20. Okay, so for our final equation, let's take a look at letter D. We have 6 times the quantity x plus 4 minus 2 times the quantity of x minus 1 is equal to 2x plus 20. Fantastic. Pause the video again and see if you can get through this problem. Little heads up, be careful when you distribute the negative 2 through that parentheses. See what you can do. All right, so this is one of these classic situations where we want to use the distributive property of multiplication first to rewrite the left-hand side of this equivalent as the left-hand side of this equation as an equivalent expression, and then we'll kind of move on from there. So the first thing I'm going to do is I'm going to distribute the 6 through this parentheses. That's going to give me 6x plus 24. Here we get the more tricky one. I need to distribute the multiplication by -2, so I'll get -2x plus 2. That's absolutely critical. 2x plus 20. Now, on the left-hand side, all I'm going to be doing is combining these terms, right, to get an equivalent expression. I'm not actually solving the equation at this point yet. Now, at this level, we're now back to where we were in B, where I simply have variables on both sides of the equation, so I'm going to try to move them both to the left-hand side, giving me 2x plus 26 is equal to 20. I now have a two-step equation, so I'm going to subtract off 26 from both sides. Try to give myself a little bit more room. 2x is equal to -6. Just got to watch that subtraction. And now -6 divided by 2 gives me an x value of -3. Some just straightforward, simple kind of equation solving, nothing higher than the 8th grade level in this problem. All right. Now, it's interesting that like everything that we've done here in those equations relies on either a property of equality or a property of real numbers. So each step in solving an equation either involves a property of real numbers like the associative, the distributive, or the commutative property. And we actually used all of those when we were solving those equations, even if I never really pointed it out. Or a property of equality, such as the addition, subtraction, multiplication, or division properties of equality. Now, as a little note, some textbooks will only talk about the addition and multiplication properties of equality. Some will add in the subtraction and division properties of equality. The reason that a lot of times they only talk about addition and multiplication is that we can always think about subtraction as just adding the opposite of whatever we're doing. And likewise, we can always think about division as multiplying by a number's reciprocal. And what I mean by that is if we were to divide both sides of an equation by 2, we can think about that as multiplying both sides of the equation by 1/2. All right, that being said, let's take a look at exercise number 2. Justify each step in solving 2 times the quantity x plus 7 plus 4x equals 44 using either a property of real numbers, commutative, associative, or distributive, or a property of equality, additive or multiplicative. So in other words, here they don't want you to really say the subtraction property of equality or the division property of equality, just either addition or multiplication. So what I'd like you to do is I'd like you to look at this equation solving that's happened here, right? Even if you wouldn't necessarily put in every one of these steps. And I'd like you to then, in each one of the blanks, ask yourself, what exactly happened when we went from this step to this step? Then you're going to write that in here. What happened when we went from this step to this step in here? And again, when I say what happened is specifically, was it the commutative property? Was it the associative property? Was it the additive property, etc.? So pause the video now and see if you can figure out each one of these steps. All right, let's go through it. So, from the first step to the second step, what we see is that the 2 has been multiplied through this parentheses to get 2x plus 14. That's probably one of the easiest ones to see. That is the distributive property, right? Whenever we multiply through a parentheses or divide through a parentheses by a constant or a variable, it's the distributive property. Now, as we go from this line down to this line, what we see is simply that 14 plus 4x has become 4x plus 14. That is, of course, the commutative property of addition. The idea that if we take two things that are being added and we reverse the order in which they're added, that is the commutative property of addition. Now, this next step, I've factored an x out of both a 2x and a 4x like this. That might be the trickiest one. That's actually still the distributive property again, right? It's just sort of running the distributive property in reverse, if you will. All right. Now, there's nothing when we go from here to here because that's just adding 2 plus 4 equals 6. I'm not even sure what you would do there. But to go from this line to this line, we've subtracted 14 from both sides. Now, I would completely and utterly on a test take the subtraction property of equality or the subtractive property of equality. Either one of those would be fine. I know that they would take it on a state exam, right? If it was just sort of like, hey, put whatever property down. Here, though, they're specifically saying use either the additive or the multiplicative property, so we're going to go with the additive property there, because what we can do is we can say, well, we added negative 14 to both sides of the equation. Finally, the last real step here, 6x equals 30, dividing both sides by 6, we're going to go back and we're going to call that the multiplicative property of equality, because again, what we're really doing is multiplying both sides of this equation by 1/6. And again, if you put the division property of equality in there, I'd be completely okay with that as well. The point is, every step when we solve an equation has a reason or a justification for why we can do that step, all right? And that's important. This isn't magic, you know, it's not arbitrary, right? We are doing these steps either because there's some property of numbers that is always true, whether those numbers are variables or known numbers, or there's some property of equality, like, hey, I can add the same thing to both sides of the equal sign and it's still true, or I can divide both sides of an equal sign by some number and it's still true, as long as the number's not 0. Anyhow, let's keep moving on. All right, equations with strange solutions. Now, normally linear equations, again, equations where the variable is to the first power, have one solution, all right? Some linear equations, though, have no solutions at all, and these are known as inconsistent equations. I just moved my little pen icon so you don't have to see it sitting there, right? So if I've got a linear equation that has no solutions, and that can definitely happen, that's what's known as an inconsistent equation. Some linear equations, every value of the substitution variable is a solution, literally an infinite number of solutions. And when this happens, the equation is known as an identity. And it really is just expressing the equality between two equivalent expressions, you know? That's all it's saying. So what we're going to do for the rest of this lesson is just play around with trying to figure out whether equations are inconsistent, i.e. they have no solutions at all, or they're identities, meaning every value of x is a solution, or they're just normal linear equations that have one solution. All right, let's take a look at exercise number 3. Try to solve the following equation. State whether the equation is an identity or inconsistent. Explain. All right, so what I'd like you to do, this is very similar to the one that we solved in exercise number 1. I'd like you to pause the video and go ahead and try to solve this equation as much as you can, as far as you can, until you get something that kind of makes you go, that seems odd. So pause the video now and see what you can do. All right, let's go through it. So just like before, what I'm going to do is the first thing, I'm going to distribute that -2. Just have to be careful there. -2x minus 8. On the right-hand side, I'm going to distribute that 3x squared plus 6, plus x minus 5. I'm going to combine some like terms on both sides of this equation. On this side, I'm going to have 4x minus 8. And on this side, I'm going to have 4x plus 1. All right. And already something seems a little bit strange to me, but I'm going to keep going ahead and doing this. I'm going to try to get all my variables on one side of the equation by subtracting 4x from both sides of the equation, and I'll get -8 is equal to +1, because all the x's have gone away. Now, what's interesting here is, of course, -x equals 1 is false, right? And there's absolutely no value of x that will ever make -8 equal to 1, right? It just can't happen. So this is what's called an inconsistent equation. There are no solutions. And really, I should almost be able to spot that, well, maybe not there, but I should be able to spot that even at this point. Okay, at the point where I have 4x minus 8 is equal to 4x plus 1, it should make sense that this equation can't have any solutions. And let me explain why, right? 4x is just some quantity. and it's here and here, right? So if I take some quantity and I subtract 8 from it, and I take the same quantity and I add 1 to it, there's no getting around it. Those two quantities can't ever be the same. I don't care what x is. You know, it doesn't matter what x is. If I take some number, which 4x is some number, and I subtract 8 from it and I add 1 to it, whatever's over here is going to be 9 units more than whatever is over here, regardless of what the value of x is. So there's no value of x that will ever make the two equal, ever. But if you really need something to make it real clear, you can always spot an inconsistent equation, because eventually, if you keep going, all the values of x will simply sort of go away, and you'll get some kind of statement like this, which is always false. Okay, let's keep going. Exercise number 4. An identity is an equation that is true for all values of the substitution variable. And that's just a fancy term for saying the variable that's in the equation. Trying to solve them can lead to confusing situations. Consider the equation 2x minus 6 plus x minus 1 is equal to 3 times the quantity x minus 3 plus 2. Letter A. Test the values of x equals 5 and x equals 3 in this equation. Show that they are both solutions. Now again, what's kind of interesting about this is that this is a linear equation, x to the first, and we expect linear equations to have at most one solution. So if both of these are solutions to this equation, that's going to seem a little bit odd. Now if it was an x squared, 2 solutions is exactly what we expect. X cubed, 3 solutions, etc. Right? But x to the first, we're thinking only 1. So let's together test x equals 5 in the equation. Then we'll have you test x equals 3 on your own, and we'll show that they're both solutions. Let's go ahead and do x equals 5 together. All right, here we go. So obviously, to test a value, to see if a value is a solution, we've been doing this for years, I am just going to plug that number into the equation wherever there's an x, and I'm going to see whether or not the two sides are equal. All right, just got to do a little bit of numerical work here. I've got 10 minus 6 plus 5 minus 1 is equal to 3 times 2 plus 2. Here I'll have 4 plus 5 minus 1 is equal to 6 plus 2. And then I'll have 9 minus 1 is equal to 8. And 8 is equal to 8. So yes, that tells me that x equals 5 must be a solution. What I'd like you to do now is take x equals 3 and go through the same procedure over here. All right, let's do that really quickly together. For x equals 3, I'm going to have 2 times 3 minus 6 plus 3 minus 1 is equal to 3 times 3 minus 3 plus 2. Here I'll get 6 minus 6 plus 3 minus 1 equals 3 times 0 plus 2. 6 minus 6 is 0, so 0 plus 3 minus 1. 3 times 0 is 0, so 0 plus 2. So now I'll have 3 minus 1 is equal to 2, and 2 is equal to 2. All right, awesome. So both of these are solutions. And again, right away that would tell us that something a little bit strange is going on, simply because a linear equation we expect to have at most one solution. All right, let's now do exactly what we did with that inconsistent equation and start to work on this thing until we see that it's an identity. And actually, let's go through this one together. All right? So here we go. Let's just pretend we're solving this like any other equation. What I'm going to do is I'm going to combine like terms on this side. 2x plus x is going to be 3x. Negative 6 minus 1 is negative 7. On this side, I'm going to distribute that 3 using the distributive property. So I'm going to get 3x minus 9 plus 2. On this side, I'm not going to do anything right now. I'm just going to leave it as 3x minus 7 and get rid of that because I don't know why I even put it there. On this side, that negative 9 plus 2 is going to be a negative 7. And I'm going to get 3x minus 7. So I'm going to pause for a moment, right? At this point, right, I've got 3x minus 7 equals 3x minus 7. And I hope you can now see why this is an identity. Okay? Any value of x that I put in is going to clearly make the left-hand side equal to the right-hand side, because they are algebraically identical. In other words, like even though, going all the way back to the beginning, even though this looks very different from this, the left-hand side looks very different from the right-hand side, they're actually equivalent expressions. And what we know about equivalent expressions is that no matter what value of x I put in here and here, as long as I put the same one in both sides, the two sides are going to be equal. And that is the definition of a solution to an equation. It is a value of the replacement variable that makes the left-hand side of the equation equal the right-hand side. So I claim you shouldn't go any further than this. Once you get these two to look the same, stop. All values of x will make this true. So one of the reasons that I say stop is that some students will do things like they'll subtract 3x from both sides and they'll get -7 equals -7, and then they'll say, well, x equals -7 is the solution. And by the way, -7 is a solution to this equation, but that has nothing to do with the fact that there's a -7 on both sides of this equation. That has to do with the fact that every value of x is a solution to this equation, including the two that we looked at up there, all right? So what I always suggest in trying to determine whether something is an identity is simply work both sides of the equation until you see an identical expression on the two sides, and at that point, you know every value of x is going to work, because no matter what you put in here, it's going to be equal to whatever you put in there. All right, let's keep going. Now, exercise number 5. Which of the following equations are identities, which are inconsistent, and which are neither? All right, so I've got kind of a nice mix here. I've got 4 equations. Some of them are identities, some of them are inconsistent, and some of them might be neither. Might be. Who knows? Maybe I didn't have any of those in there. Anyway, what I'd like you to do is work through letter A and see if you can figure out which one it is. All right, let's work it through. And again, I don't want to do more work than I have to. Once I know which type it is, I'm going to stop. But the first thing I have to do is distribute. All right, I'm going to combine some like terms. I'm going to get 6x minus 6 is equal to 6x minus 5. And at least at this point, for me, I'm good to go. I know this is going to be inconsistent. And I know it's going to be inconsistent because these two expressions are almost identical, except this is a minus 6 and this is a minus 5. Now, if that's not good enough for you, right, what you could certainly do is subtract a 6x off of both sides. And you'll get -6 is equal to -5. And -6 is never equal to -5. No matter how bad of a day -5 is having, it won't be equal to -6. And therefore, this is an inconsistent equation. Again, you'll get people that'll say, oh, no, you know, that means that -6 is a solution or that -5 is a solution. No. You know, if I ask you what value of x makes -6 equal to -5, your answer should be, there's no value of x that will do that, right? There's nothing at all in this universe that will make -6 equal to -5, and therefore it is inconsistent. All right, why don't you go ahead and play around with letter B. All right, now this one kind of looks ugly until you realize that really this fraction, this division by 2, is no different than this multiplication by 2. I'm going to just distribute the division by 2 right away. All right, 4x divided by 2 is 2x. 2 divided by 2 is 1. Plus 8 is equal to 2x plus 9. I'm going to combine like terms on this side, and I'm going to get 2x plus 9 is equal to 2x plus 9. And at this point, I've got to stop. All right, I mean, there's just nothing more I can do on this. 2x plus 9 is going to be equal to 2x plus 9 for every value of x that's out there, and therefore this is an identity. All right, every value of x is going to work. Let's take a look at letter C. Why don't you go ahead and play around with that one? All right, let's do it. First thing I'm going to do on the left-hand side is I'm going to distribute that -1, which is going to change the x into a negative x and the -7 into a positive 7. On the right-hand side, I'll distribute that multiplication by 2. I will combine like terms on this side. I'll get 3x plus 15 is equal to 4x minus 6. Maybe I'll subtract a 3x from both sides. That will give me 15 is equal to x minus 6. And maybe I'll add 6 to both sides. And I'll get x is equal to 21. Let me just make sure that looks good, I think. Yep. Now, that means it's neither, right? So remember, we were looking at equations that either had no solutions, like letter A, that had every value of x as a solution, that was letter B, that was an identity, or neither. In other words, it's just your garden variety, like linear equation that has one solution. So that's this one. Now, you may have been able to figure that out earlier. There wasn't anything that said we actually had to solve it all the way. And in fact, I claim that even by the time you're at this level, 3x plus 15 equals 4x minus 6, you're probably well aware that, yeah, that's actually going to be just neither. It's going to be just your normal, everyday linear equation. All right, take a look at one more. Try letter D. All right, let's do it. On the left-hand side, we've got to do a little bit of distribution. So I'm going to do 2x plus 1 is equal, whoops, not equal to, plus 2x minus 2. I'm going to distribute the division by 4 here. I'll get 4x minus 1. Here I can combine these two terms. 2x and 2x is 4x. Positive 1, negative 2 is negative 1. 4x minus 1 here, and we're done. This is an identity. Every value of x will solve 4x minus 1 equals 4x minus 1. All right, let's wrap this up. Everything that we did today should have been review, especially just the solving of linear equations. All right, this is a skill that you absolutely positively must have at this point in Algebra 2. We aren't going to do any more review of it, right? I mean, these equations will just naturally pop up here and there in various problems. They might be the end part of some larger equation solving technique that you learn, all right? And as well as that, we looked at these equations that have no solutions at all, which are often the case in math, and they're often important cases. And less often, we looked at equations that have an infinite number of solutions, in fact, equations where every value of x is a solution, and those are known as identities. All right, all of this is very important information, but especially simply the ability to solve linear equations. All right, well, I want to thank you for joining me for another Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.